Welcome to the Deep Dive, where we really pull back the curtain on the built environment all around us. We explore those hidden forces shaping our health, our well-being. And today, we're zeroing in on something many of us might, subconsciously know, but maybe rarely think about. That kind of distinctive smell in a new building or a freshly painted room. While we often just dismiss it as the smell of new, well, that scent is frequently a really complex chemical signature. We're talking volatile organic compounds, or VOCs, stuff that's off-gassing from materials all around us. So today, we're taking a deep dive into how a really crucial global standard for sustainable construction, LEED v5, specifically tackles this invisible challenge. It does this through its low-emitting materials credit. We're going to unpack the, pretty stringent requirements and the detailed criteria that the LEED program sets, all to make sure the materials used in our buildings actually contribute to healthier indoor environments. Our goal for you today is to walk away not just informed, but really with a profound understanding of why these standards aren't just some abstract green label. They're really a direct investment in human health. And we'll look at how project teams actually achieve this vital objective. We've been meticulously sifting through the main document here, LEED v5 Low-Emitting Materials, requirements and criteria, to pull out the most essential nuggets for you. Now, before we jump into all the fascinating details about paints, flooring, furniture, and all that, if you're as intrigued as we are by this hidden world of sustainable design and, the profound impact our built environment has on us, make sure to hit that subscribe button. That way you'll hear more about this world in our future deep dives. Okay, let's unpack this then. Before we get too bogged down in the percentages and the certifications, let's zoom out a bit. Why do we even have a credit like low-emitting materials in LEED v5? What's the core problem it's trying to solve? Not just for the environment, but, for us, the occupants.
Yeah, that's really the foundational question, isn't it? And the intent behind this credit, it's beautifully clear and kind of multifaceted. Fundamentally, it's about mitigating this pervasive issue of indoor air pollution.
Right. We hear so much about outdoor air quality.
Exactly. But the thing is, studies consistently show that indoor air can be, way worse, sometimes 2 to 5 times, and sometimes even 100 times more polluted than the air outside.
100 times, wow.
Yeah. It's mainly because buildings, they just contain this concentrated cocktail of materials, right? And they're continually releasing chemicals. So the first aim is to significantly reduce the concentrations of these chemical contaminants, things like volatile organic compounds, VOCs, you hear about them a lot, and formaldehyde. These can severely compromise our indoor air quality. And by extension, the broader environment, too, as they eventually, dissipate outdoors.
Okay, so it's about cleaner air inside, which eventually helps outside, too.
Precisely. But the why goes much deeper than just those environmental metrics. It's profoundly about human health and comfort. And it impacts everyone. Think about the construction workers installing these materials, often in spaces that aren't well ventilated yet.
Yeah, that's a good point.
And then, of course, the long-term occupants, people who spend, 90% of their lives indoors.
That statistic is always staggering. 90%.
It is. And consider the impact. VOCs, they can off-gas for years, contributing to what people sometimes call sick building syndrome, manifesting as headaches, dizziness, nausea, just feeling generally unwell.
Right, that vague blah feeling you can get sometimes.
Exactly. And formaldehyde, which you often find in composite wood products like particle board, that's particularly insidious, it's not only a potent irritant for your eyes, nose, throat, it's also a known human carcinogen.
A carcinogen? Okay, that's serious.
It is. And beyond those immediate sort of acute effects, there's growing research on the long-term chronic health issues, things like respiratory problems, asthma, allergies, even reproductive issues and neurocognitive impacts.
Neurocognitive?
Yeah.
Like affecting how we think?
Yes, exactly. There was a landmark Harvard study, actually, that showed workers in certified green buildings, which specifically had lower VOC levels, they performed significantly better on cognitive tests, things like decision-making, how they used information, strategic thinking.
So better air literally means thinking clearer.
It suggests that, this isn't just some abstract health concern. It has tangible economic implications, too. Reduce productivity, increase healthcare costs. So this credit isn't just about getting a green label. It's a direct, measurable intervention for public health, for human flourishing within the buildings we spend so much time in.
So it's really not just a label at all. It's about tangible benefits, immediate and long-term, for everyone from the construction site to the corner office. So how does this specific credit, low-emitting materials, fit into that larger, sometimes pretty intricate LED framework? And what kind of recognition does a project actually get for meeting these tough criteria?
Right, connecting it to the bigger picture. This is a crucial materials and resources credit. Its specific designation is MRc3, and that's within the LEED BD plus C new construction V5 system. BD plus C being building design and construction.
Gotcha. Materials and resources, MRc3.
Exactly, and that whole materials and resources category, it's one of the 7 key credit categories in LEED. It's designed to really encourage teams to select products that are environmentally preferable, throughout their entire life cycle, from cradle to grave, essentially. So by achieving MRC3, a project signals a really deep commitment, a commitment to reducing the environmental footprint of the materials and, critically, enhancing indoor environmental quality, which is a huge piece of the puzzle. Projects can earn up to 2 possible points towards their overall LE certification for just this one credit.
2 points. And in a LEED, every point definitely counts.
Oh, absolutely. In the, let's say, competitive world of green building, every single point is a testament to the project team's dedication. It shows they've gone beyond just standard practice to create spaces that are healthier, more sustainable. These points, they aren't just symbolic. They translate that design philosophy into measurable, verifiable impacts on the people inside the building. And that's increasingly a top priority for developers, for building owners, and definitely for tenants.
Makes sense. It's becoming a real market differentiator.
It really is. It's a mark of a truly high-performing, responsible building.
Okay, so we've established the why health, environment, points. Let's talk about the what. When we talk about low-emitting materials, my mind, like I said, jumps straight to paint. Probably because it's so visible and you smell it right away, but I'm guessing it's a lot broader than just what's on the walls.
You are absolutely right to broaden that scope, significantly beyond just paint.
Okay.
While paints and coatings are definitely included, yes, the requirements specifically target a really wide array of permanently installed products. Products that are integral to the finished interior space and ones that are known sources of emissions.
Permanently installed. That's a key phrase.
It is. So we're looking at interior paints and coatings, yes.
Yeah.
But also a really comprehensive list. Think adhesives and sealants, the stuff holding things together, all types of flooring, the materials used for interior walls and ceilings, various forms of insulation. Furniture, which, can be a surprisingly large emitter, especially systems furniture.
Furniture, really? Okay.
Oh, yeah. And composite wood products. Those have unique emission concerns, particularly around formaldehyde, as we mentioned. The fundamental idea here is to capture those elements that are both, extensive in their use within a building and have a direct, continuous impact on the indoor air quality that people breathe every single day.
Right, stuff that defines the immediate environment, the things we're surrounded by long term.
Exactly. The materials we interact with or are just near for the long haul.
That makes perfect sense.
Yeah.
If it's permanent and you're breathing near it, it should be considered. Now, this next point often seems like a critical area for project teams, kind of sorting this out. What isn't included in these criteria? And what's the thinking behind those exclusions? It seems very deliberate.
That's a crucial point, yeah. And the exclusions are indeed quite logical, strategic even, designed to focus the credit's impact where it's most needed. The LEED V5 document, it specifies that several types of materials and systems are considered not applicable to these low-emitting materials categories.
Okay, like what?
For instance, structural elements. Things like structural framing, whether it's steel or heavy timber and poured concrete. The literal skeleton of the building.
The bones.
The bones, exactly. The rationale there is that their main job is structural integrity, right? And they aren't typically significant long-term sources of the specific VOCs or formaldehyde that this credit targets. I mean, sure, concrete can off-gas some compounds initially, but its emissions profile is generally different. Less impactful on long-term indoor air quality than, say, synthetic carpet or paint.
Okay, so structural stuff is out. What else?
Similarly, various building systems are also excluded. This includes things like fire suppression equipment, all the HVAC systems, including the ductwork, plumbing components, electrical wiring and fixtures, conveying systems like elevators, communications infrastructure, all that kind of operational stuff.
Why are those out? Some of them have plastics or chemicals, right?
They do, but the reason is kind of multifaceted. First, their primary function is mechanical or operational. And they're usually covered by other performance standards within LEED that look at their energy efficiency or water use or other environmental impacts.
Okay. Different credits cover them.
Right. And second, while some components might contain plastics or chemicals, their design and how they're installed usually minimizes their direct continuous contribution to indoor air VOCs. Not in the same way a paint or an adhesive might, anyway. Like ductwork materials, they're designed for airflow, not really meant to be primary chemical emitters into the space they serve.
Got it. That makes sense. Any other major exclusions?
Yeah, finally, specific building envelope components. Things like structural insulated panels, SIPs, or water-resistant barriers, the membranes you put on the outside. While they're vital for building performance, their role is typically behind the finished interior surfaces.
Right, they get covered up.
Exactly. Once they're installed and covered by drywall or whatever, their potential to directly contribute to indoor air emissions is greatly reduced. Their job is mainly about moisture management or structural performance, not directly impacting the indoor air once they're sealed in. So really, these exclusions allow project teams to focus their efforts, their time, their resources on the materials that have the most direct and continuous impact on indoor air quality and occupant health.
Ensures the credit drives meaningful change where it matters most for breathing.
Precisely.
Okay, so let's imagine our listener, Sarah, an architect, designing a new sustainable community center. She needs a clear roadmap for this. The document outlines different pathways to earn points. Can you walk us through those? How does a project like Sarah's actually get to 1 point or maybe 2 points? And what are the strategic thoughts behind choosing one path over another?
Indeed. For Sarah and your team, understanding these pathways is absolutely critical for planning, for budgeting, everything. The LEED V5 document outlines 3 distinct paths. They're detailed in Table 1 for new construction projects. Each requires, increasing levels of commitment, but also offers some flexibility. Let's start with Path 1, the foundation. This gets you 1 point.
The baseline.
Exactly. It's the non-negotiable baseline. To secure this point, a project must achieve compliance for 3 core, highly visible, widely used interior categories. Those are paints and coatings, flooring, and ceilings.
Okay, big surface areas.
Right. And the threshold here is quite stringent. More than 90% of all products in each of these 3 product categories must meet the low-emitting criteria.
Wow, 90% in each one. That's high.
It is. This isn't just picking a low VOC paint for one room. It demands a comprehensive, overarching commitment across the most extensive surfaces inside. These materials are foundational, right, to the look, the feel of a space. So their emission profile is paramount. It means Sarah's Community Center needs nearly all its paint, all its carpet or tile, all its ceiling panels to be certified low-emitting.
Okay, that's the first point. How do they get to 2?
Right. Now, if Sarah's team wants to push further for 2 points, they have 2 options. Path 2, expanding the scope. To earn 2 points this way, a project first needs to fully achieve all the requirements of Path 1. So those core 3 are done.
Got to do Path 1 first.
Got to do Path 1 first. Then they must include any 2 additional product categories from a specific curated list. That list is adhesives and sealants, walls, insulation, or composite wood.
Pick 2 from those 4.
Pick 2. And for these additional chosen categories, the threshold is more than 80% of each chosen category.
Okay, 80% for the additional ones, not 90.
Correct. A bit more flexibility there. This path offers significant flexibility, really. It lets project teams tailor their approach, maybe based on specific design features or material availability in their region, or even the project's budget and construction methods. For a community center like Sarah's, maybe it has extensive built-in cabinetry that falls under composite wood or specific acoustic wall treatments. Choosing walls and composite wood could be a very strategic way to get those extra points.
Okay, that's Path 2. What's the other option for 2 points?
The other option is Path 3, focusing on occupant experience. This also requires achieving Path 1 first. Always got to do Path 1.
Path 1 is the key.
It's the key. But instead of picking 2 categories from that list, Path 3 specifically targets furniture. If a project achieves Path 1 and then ensures that more than 80% of the furniture product category meets the low-emitting criteria, they also earn 2 points.
So it's Path 1 plus furniture at 80%.
Exactly. This path really zeroes in on that direct, often prolonged interaction people have with furniture. Imagine people spending hours in meeting rooms, at workstations, maybe relaxing in lounges in Sarah's Community Center. The emissions from that furniture are literally in their personal breathing zone, so it's a very impactful area to address for health and comfort.
Okay, so what does this all mean for a design team like Sarah's then? It sounds like a genuinely strategic decision has to be made. You're weighing different factors beyond just, how things look. Why would someone choose, say, Path 2 over Path 3, or the other way around, if both ultimately lead to those 2 coveted points? It feels like it's not just about hitting a number, but making these deeply informed choices that align with the project's specific goals. Maybe it's budget, too.
That's an excellent question, and it really gets to the heart of how project teams approach LE successfully. The choice between Path 2 and Path 3, it's rarely arbitrary. It's a strategic calculation, like you said,
Right.
tailored to the specific project type, its budget, its functional needs. For instance, let's think about Sarah's Community Center again. If it's designed with a strong emphasis on, say, flexible learning spaces, large meeting rooms with lots of systems furniture, maybe a dedicated co-working area, then focusing on furniture Path 3 might be the most logical and impactful choice.
Because there's just so much of it.
Exactly.
Yeah.
The sheer volume and cost of furniture in a project like that would make achieving 80% low-emitting compliance for that category a powerful statement about occupant health and a clear path to those 2 points. They might have a substantial budget for ergonomic chairs, modular desks, maybe custom reception desks. All of that would then fall under this pathway. The project team would need to engage furniture manufacturers early on, make sure certified products are specified.
Okay, so that's the furniture-heavy scenario. What about the alternative?
Conversely, maybe Sarah's Community Center has lots of built-in wall systems for art displays or acoustic panels everywhere, maybe extensive use of insulation for sound control in a music room, or perhaps specific structural panels, which might be composite wood, in a really high-traffic area like a gymnasium. In that case, Path 2, targeting walls, insulation, or composite wood, might be more achievable or even more cost-effective.
If the design leans that way.
Right. They might have a smaller budget for loose furniture, or maybe their design naturally emphasizes built-in elements over standalone pieces. Think about a healthcare facility, for example. They have strict infection control rules for wall finishes, extensive insulation needs for sound privacy between rooms. Path 2 might be the overwhelming choice there.
That makes sense. And you mentioned the percentages differ too, 90%, 80%.
Yeah, the differing percentages, 90% for Path 1's core categories versus 80% for the additional ones in Paths 2 and 3, that also plays a subtle but important role. The 90% threshold for paints, flooring, and ceilings, it kind of reflects that these are mature product categories. Compliant options are generally widely available, relatively cost competitive now.
Easier to hit 90.
Generally, yeah.
Yeah.
The 80% threshold for the additional categories offers a bit more flexibility. It acknowledges that sourcing 100% compliant materials in every single specialized category might be challenging, or for certain highly specialized products, may be cost prohibitive.
Gives some wiggle room.
Exactly. It allows project teams to make pragmatic choices while still achieving a very high standard overall for low-emitting materials. It ensures that baseline commitment in Path 1 then allows for strategic, impactful expansion. So the key insight for Sarah really is to analyze her project's material palette early, very early, and identify which path provides the most significant health benefit and is most feasible within her project's unique constraints.
That's incredibly helpful for the strategic planning side. But the devil, as they say, is often in the details. Let's get really granular now, because I can see how confusion could arise. What exactly counts as flooring versus, say, a wall treatment, or what's included in furniture? Can you break down some of these key categories, like specific inclusions and exclusions? This will really help our listeners and designers like Sarah grasp the nuances project teams grapple with for accurate compliance.
Absolutely. This level of detail is, well, paramount for accurate project documentation and successful compliance. Misinterpreting a category can definitely lead to significant headaches, maybe even missed points down the line. LEED's definitions are incredibly precise to try and prevent that ambiguity. Let's really dissect a few of the most complex or maybe frequently misunderstood categories.
Okay, let's go.
First, paints and coatings. This category specifically includes all interior paints and coatings that are wet applied on-site.
Wet applied on-site. Keywords again.
Keywords. So if Sarah's Community Center has a vibrant mural painted directly onto a wall, or just standard primer and top coats, it's in scope. This also includes clear finishes, stains, even specialized anti-graffiti coatings if they're wet applied inside. However, it explicitly excludes foamed in place and sprayed insulation, even though they are wet applied.
Ah, okay. Why is that?
It's because those types of insulation have really distinct emission profiles, primarily related to their expanding chemical reactions during installation, so they're rightly categorized under the broader insulation category, which reflects their main function and how they're put in.
Got it. Insulation is its own thing.
Exactly. Next up, adhesives and sealants. This refers to all interior adhesives and sealants that are, again, wet applied on site. And this is a remarkably broad category. It covers everything from general construction adhesives used to bond large materials together to more specialized glues, maybe for installing air or vapor barrier membranes inside the building envelope, and even floor setting materials like the thin-set mortar for ceramic tiles or the various glues used for sticking down carpet tiles or vinyl flooring.
So basically any sticky stuff applied wet inside.
Pretty much. If it's a wet product used to stick or seal components together inside the building, it probably falls here. It's the hidden glue holding things together, and its emissions can be pretty significant.
Okay. What about flooring? That seems huge.
It is. Flooring is a very comprehensive category. It covers non-structural flooring elements, and it's critical, like you said, given its vast surface area in most buildings. It includes virtually all types of hard and soft surface finishes you'd expect. Carpet, both broadloom and tiles, ceramic tile, vinyl like LVT or VCT, rubber, engineered wood, solid wood planks, natural stone, laminates.
The usual suspects.
The usual suspects. But beyond the aesthetic surface, it also covers functional components like raised flooring systems, those entryway walk-off systems designed to trap dirt at entrances, area rugs if they're purchased specifically for the project, wood subflooring, underlayments that go beneath the finished flooring, and even specific air barrier and vapor barrier membranes if these are used inside an air barrier membrane system. That shows how layered modern building envelopes can be.
Wow. Okay. What's excluded from flooring then?
Good question. Poured concrete is excluded because that's considered a structural element. Composite wood subflooring is also excluded from this category. Its main emission concern is formaldehyde, so it goes into the composite wood category instead.
Oh, makes sense. Grouping by emission type.
Exactly. And crucially, any wet applied products applied on the floor, those fall into the adhesive sealants category, or maybe paints coatings, depending on what they are.
So the adhesive for Sarah's carpet tiles is an adhesive, not flooring.
Correct. The adhesive is assessed separately.
Okay, what about walls?
Right, walls. This category focuses on non-structural wall materials. This means all finished wall treatments like wall coverings, think wallpaper, fabric panels, or wall tile. Decorative finished carpentry, like custom millwork, wood paneling, interior railings, trim moldings, standard gypsum wallboard, drywall,
Right.
wall base, or skirting boards, both interior and exterior doors because their interior surfaces are exposed to the indoor air.
Interesting. Even exterior doors count on the inside face.
Yes. Also, non-structural wall framing, like light gauge steel studs, and non-structural sandwich panels used in wall construction. Exclusions here are important too. Any wet applied products put on the wall, those are paints or adhesives. Case goods, built-in cabinetry, and countertops, these are explicitly defined as part of the furniture category, often because they're factory finished items.
Okay, cabinetry is furniture, not walls. Good distinction.
Very important distinction. Also excluded are smaller items like bathroom accessories, door hardware, and large-scale curtain wall or storefront systems. Those have different criteria.
All right. And furniture itself, you said that was a big one.
It is huge, and often underestimated for its emission potential, like we discussed. Furniture encompasses practically all furniture within the project's scope, whether it's fixed or movable.
All of it.
Pretty much. We're talking permanently installed office furniture, entire cubicle or systems furniture setups, loose seating, chairs, sofas, desks, tables, filing cabinets, storage units, specialty items like library apparels, beds if it's a residential or hospitality project, case goods like dressers or credenzas, casework, which is built-in cabinets, shelves, countertops, movable or demountable partitions, bathroom or toilet partitions, shelving units, lockers, retail fixtures including slat wall, even window treatments like blinds or shades.
Window treatments too, wow.
Yep. And it even extends to furnishing items like non-fixed area rugs separate from the installed flooring category. We talked about cubicle curtains and mattresses if purchased for the project. Now, for custom items, which Sarah's community center might have, like that reception desk example, they meet the criteria if all components of the finished piece, whether applied on-site or off-site, meet the VOC criteria within the furniture category, or if the finished piece itself as a whole meets the overall furniture emissions or VOC emissions criteria through testing.
So you can test the whole custom piece.
You can. Excluded from this huge category are small things, office or bathroom accessories, decorative art, recreational items like maybe a ping pong table, cabinet, and drawer hardware, and planters. Their contribution is considered negligible or outside the main scope here.
Wow, that's incredibly specific and really paints a clearer picture.
Yeah.
So if Sarah's designing that new reception area for her community center, and she specs custom cabinetry for the welcome desk, She now knows definitively that's part of the furniture category, not walls, which is crucial for compliance, especially when you think about the different testing standards.
Absolutely crucial.
It really highlights the need for meticulous planning and understanding these definitions right from the absolute start of a project, not as an afterthought.
Couldn't agree more. It has to be integrated from day one.
Okay, we've covered the what materials are included and how many you need for the different point pathways. But the absolute core question still remains. How do you actually prove that a specific product is low emitting? What are the technical benchmarks, the scientific evidence required? Because without rigorous testing and verifiable standards, these are just, well, good intentions.
Exactly. This is where the science, the engineering, the independent certification bodies all come in. They provide the necessary backbone for the entire credit. It ensures that low emitting isn't just some marketing claim slapped on a can, but a scientifically verified fact. There are specific evaluation criteria for VOCs, volatile organic compounds, for furniture emissions, and for formaldehyde emissions. Each one is rigorously tailored to the unique characteristics and potential health concerns of those material types.
Okay, let's break those down. What about VOCs generally?
Okay, for VOC emissions evaluation criteria, the primary and really the most robust way to prove VOC compliance is through third-party certification. This means a product has been independently tested by a qualified lab and it complies with the California Department of Public Health, CDPH, Standard Method V1.2 Talcios 17.
CDPH V1.2. Okay.
Right. And this isn't just a simple sniff test, it's a comprehensive chamber testing protocol. It simulates real-world indoor environments. It measures a wide range of specific VOCs emitted from the product over time. And it uses specific exposure scenarios to calculate acceptable emission levels. The most common scenario used is the private office scenario, representing a typical individual workspace. But for products used in schools, like in Sarah's community center classrooms, a more stringent school scenario can also be applied. It has even tighter emission limits.
Makes sense for kids.
Absolutely.
Right.
This CDPH standard, it's rigorous, it's widely recognized. It has effectively become a de facto global standard for indoor air quality testing for materials.
It is truly fascinating how California standards, like that CDPH method, have become such a powerful benchmark for the whole industry, not just in the U.S., but globally. It really speaks to the rigorous research and, frankly, the leadership from that region in pushing for healthier indoor environments. It's influenced manufacturers everywhere.
Absolutely. It's a remarkable example of how regional innovation can really set global precedents. Manufacturers all over the world now design and test their products to meet this stringent CDPH method, even if they don't directly sell into California. Why? Because it's recognized as the best-in-class standard. It opens up markets.
Okay, so third-party certification to CDPH is the main way. Are there alternatives?
There are. If a product doesn't have that full third-party certification mark, but it has undergone the proper testing, a project can potentially use a qualified independent laboratory report. This report has to show that the product underwent testing within 3 years prior to purchase, using the exact same CDPH standard method. And the report must demonstrably show the product meets the VOC limits specified in Table 4.1 of whichever scenario was chosen, office or school.
So same test, same limits, just maybe not the official certification label yet.
Essentially, yes. It provides some flexibility while maintaining that scientific rigor. And then the simplest pathway for VOCs is if the product is inherently non-emitting, salvaged, or reused. We'll dig into salvage trees more in a moment.
Inherently non-emitting, like stone or metal.
Exactly. Things like solid ceramic tile, stone, unfinished metal, glass, materials that by their very nature, don't off-gas significant levels of the targeted chemicals once installed.
Okay. What about the specific criteria for furniture? You said that was separate.
Right. Furniture emissions evaluation criteria. Furniture gets its own specialized pathway, partly because it's often this complex mix, composite woods, fabrics, foams, adhesives, finishes, all interacting, and also because of that close, prolonged interaction occupants have with it.
Right, you're sitting right next to it all day.
Exactly. So the primary method here is through qualifying third-party certification based on ANSI-BIFMA Standard Method M7.1 2021.
ANSI-BIFMA M7.1. Different standard.
Different standards, specifically for furniture emissions testing. This certification also needs to show compliance with specific sections of the ANSI-BIFMA E3 2014 or E3 2024 Furniture Sustainability Standard. These E3 standards are comprehensive sustainability standards for furniture, covering materials, energy, social responsibility, and emissions are a critical component. Now, crucially, the compliance statements must include the specific exposure scenario used for testing. This is important.
Scenarios again, like the office or school ones.
Similar idea, but specific to furniture types and uses. For instance, seating products are evaluated using a seating scenario. Classroom furniture uses a standard school classroom scenario. Other products might use an open plan or private office scenario. And it's noteworthy that the document highlights the open plan scenario as being more stringent than the private office one.
More stringent. Why is that?
It makes sense when you think about it. Larger air volume, potentially more emitters packed into a shared space in an open plan office compared to a single private office. So the limits need to be tighter per piece.
Ah, okay. Dilution isn't as effective.
Precisely. Imagine Sarah selecting furniture for that flexible co-working space in her community center. The open plan scenario would likely be the benchmark she'd need to meet. And again, just like with general VOCs, for furniture, being inherently non-emitting, salvaged, or reused also qualifies, creates that parallel path.
Okay, and the last one was formaldehyde, specifically for composite wood.
Yes. Formaldehyde emissions evaluation criteria for composite wood. Given those specific, well-documented health concerns around formaldehyde, especially from common composite wood products like particle board or MDF, these materials have a very focused and stringent set of criteria. Formaldehyde is tricky, right? It can off-gas for a very long time, and its health effects can be cumulative.
Right.
So the main path here is third-party certification from a California Air Resources Board, CARB, approved or Environmental Protection Agency, EPA, recognized third-party certifier.
TARB or EPA recognized certified. Yeah. Okay.
And this certification must demonstrate the product is one of the following. Either certified as an ultra-low emitting formaldehyde, UF, product, that's under the EKA Toxic Substances Control Act, TSCA Title VI, or the CARB Airborne Toxic Control Measure, ATCM. These are products specifically engineered with advanced resin technologies to have extremely low formaldehyde off-gassing.
You go ultra low.
Or, even better sometimes, certified as a no-added formaldehyde resins NAF product. Again, under EPA TSCA Title VI or CRRB ATCM. These products are manufactured using resins that inherently do not contain or add formaldehyde in the first place, things like soy-based adhesives or PVA, often considered the gold standard for formaldehyde reduction.
NAF, no added formaldehyde. So ULEF or NAF are the top tiers.
Those are the top tiers for certification. Alternatively, there are some specific product standards that also qualify. Specific wood structural panels manufactured according to PS 109 or PS 210, or the CARB equivalent, and labeled with a bond classification of exposure 1 or exterior.
PS1, PS2, what are those?
PS 109 is the standard for construction and industrial plywood. PS 210 is for wood-based structural panels like OSB-oriented strand board. Meeting these standards ensures a certain level of manufacturing quality and performance that generally correlates with lower emissions and greater stability.
Okay, so certain structural panels qualify by meeting their own standards.
Right. And similarly, specific structural wood products manufactured according to other established industry standards also meet the criteria. This includes standards like ASTM D54F6 for structural composite lumber, ANSI A190.1 for glulam beams, ASTM D5055 for I-joists, ANSI PRG 320 for cross-laminated timber, CLT, or PS 2015 for finger-jointed lumber.
Wow, that's a lot of technical standards.
It is a dense list, but what's crucial to understand is that these are all well-established industry standards for structural wood products. They ensure a certain level of manufacturing quality, adhesive performance, durability, which by extension contributes to a more stable product with lower and more predictable emissions. Think of them as a robust quality control stamp that implicitly ensures a healthier product in terms of formaldehyde.
So it's not just random letters and numbers. They signify a level of quality control related to emissions.
Exactly. And just like with the others, inherently non-emitting, salvaged, or reused materials also meet these specific criteria for composite wood, recognizing their reduced emission profile over time.
This really highlights the industry's targeted response to those specific, well-documented health risks like formaldehyde. It provides clear, scientifically backed pathways to avoid those risks in the buildings we design and occupy.
It really does.
It shows a highly granular approach to materials that have historically been problematic. It gives manufacturers clear goals and designers like Sarah clear choices for ensuring occupant health.
It's a testament, really, to how meticulous standards can drive pretty profound shifts in manufacturing and material selection over time.
Okay, let's circle back to something you mentioned a few times. salvaged and reused materials. In sustainable building, reusing materials is often celebrated, right, as the ultimate form of recycling. Huge environmental benefits, reducing waste, conserving resources. How do salvaged and reused materials fit into these low-emitting criteria specifically? Is it just an automatic pass because they're old, or are there important considerations, maybe some crucial caveats?
That's an excellent point, and it's a very nuanced area that LEED has addressed quite carefully. The goal is to promote reuse, definitely, but without inadvertently introducing new indoor air quality problems.
Right, don't want to swap one problem for another?
Exactly. So the core definition for salvaged and reused materials is pretty straightforward. The product must be more than 1 year old at the time of use.
Over a year old, okay.
That age factor is crucial because the thinking is it generally allows for the significant off-gassing of many of those initial volatile compounds, the stuff released during a product's first year of life. The assumption is that by the time a material is salvaged and repurposed, the majority of the most problematic initial emissions have already dissipated, making it inherently lower emitting from that point onward.
Like that new car smell fading away.
Exactly like that. Think of a well-aged piece of furniture or an old wood beam. Much of its initial new smell is long gone. However, the interaction of salvaged materials with new products is where it gets really interesting and requires careful attention from project teams.
Ah, okay. When you combine old and new.
Right. This is a critical distinction that can make or break compliance. Let's use Sarah's community center project again as a practical example. Imagine Sarah has sourced a beautiful, old, solid wooden countertop for a reception desk. Maybe from a deconstructed building. It's definitely more than a year old, so it qualifies as salvaged.
Okay, got the old countertop.
Now, scenario 1. Applying a new product with a separate manufacturer and cost. Sarah wants to protect the salvaged countertop, so she applies a new, certified, low VOC clear sealant. The sealant is purchased from, say, paint company X, and its cost is separate from the countertop itself on the invoice.
Okay, separate sealant, separate cost.
In this situation, the salvaged wooden countertop retains its status as a low-emitting reused material because its original emissions profile is presumed stable due to its age. Only the new sealant needs to be documented separately and must meet its own applicable low-emitting criteria for paints and coatings.
So the old part is good, just check the new part.
Exactly. This approach actively encourages creative reuse, which is great for sustainability, while still ensuring that any new materials introduced to modify or phase that salvaged item are themselves low-emitting. It's kind of a win-win.
Yeah, that makes sense. What's the other scenario?
Scenario 2, applying a new product without a separate manufacturer and cost. Now, let's say Sarah sends that same old wooden countertop to a custom millwork shop. The shop integrates it into a brand new, custom-built reception desk. They apply various glues, maybe some new laminates on the edges, new finishes, all as part of creating a single new product, the desk. The cost of these applied products might just be bundled into the overall cost of the custom desk, and they might not have a separate manufacturer listed. It's all just from Millwork Shop Y.
It becomes one new thing.
Precisely. In this case, the entire finished reception desk would be considered a new product because its original salvaged component has been fundamentally altered, integrated into something new. Consequently, that combined new product no longer qualifies as inherently non-emitting based on its salvaged component alone.
Even though part of it is old wood.
Right. Instead, the entire finished piece, the whole desk, becomes subject to the general VOC emissions evaluation criteria that apply to newly manufactured furniture.
So you'd need to test the whole desk or prove all the new components meet the standard.
Exactly. This rule prevents projects from, say, taking an old, potentially high-emitting item, slapping a new coat of low VOC paint or glue on it, and then claiming the entire system is low-emitting without testing the combined result. It ensures that if you're modifying an old material in a way that really creates a new product, you're responsible for the emissions of that new composite product. It maintains the integrity of the low-emitting goal.
So what does this all mean for someone planning a renovation or designing with reclaimed materials? It seems like a powerful incentive for creative reuse and those circular economy ideas, absolutely. But with the very important caveats.
Definitely.
You have to maintain the integrity of the low-emitting goal. It's really about being smart and holistic about what you're putting into the air, even with old materials.
That's a great way to put it.
And understanding that how you treat and integrate those materials can fundamentally change their classification, their compliance requirements.
It really underscores the need for careful planning when using salvaged items.
Okay, we've covered a massive amount of ground today. From the why, the health and environmental imperative, through the what, the materials and categories, and the how, the pathways and technical proof. But, in the real world, project teams often face hurdles. This stuff isn't always easy. What are some of the most common challenges Sarah or other designers might encounter when they're actually trying to achieve this low-emitting materials credit? And maybe what are some best practices to overcome them?
That's a critical next step, isn't it? Because theory and practice can definitely diverge sometimes. One of the primary challenges, honestly, is still material availability and sourcing.
Finding the right stuff?
Finding the right stuff. While compliant products are absolutely becoming more common, finding a certified low-emitting option for every single specialized application can still be difficult, especially for niche products or maybe in certain geographic regions where the supply chain isn't as developed for green materials yet. For example, maybe a very specific type of fire-rated insulation or a particular high-performance sealant might not have as many certified low VOC options available off the shelf.
Right, the really specialized things can be tricky.
They can be. Another significant challenge is often cost. While many compliant products like paints or carpets are now pretty competitively priced with their conventional counterparts, some highly specialized or maybe premium low-emitting materials can still carry a higher initial price tag.
The green premium still exists sometimes.
It can, yeah. This requires really careful budgeting and maybe some value engineering discussions early in the design process. You have to justify that investment in healthier materials, show the long-term value, and then documentation and verification. This shouldn't be underestimated.
Work.
The paperwork. Tracking every single product used on a project, its manufacturer, its specific certification number, ensuring that certification is current, that it meets the chosen scenario's criteria. It can be a massive undertaking, especially for large projects with potentially thousands of different material inputs.
Just keeping track of it all.
Exactly. Misinterpreting a certification or maybe overlooking a small component that wasn't specified correctly can unfortunately lead to lost points later on during the review process.
Okay, so availability, cost, documentation, those are big hurdles. What about best practices? How can teams like Sarah's navigate this?
Well, early engagement is absolutely key. Cannot stress that enough. Sarah should begin collaborating with her material suppliers and manufacturers from the very earliest design stages, like schematic design even.
Get them involved early.
Get them involved early. Specifying low-emitting requirements up front in the project documents gives manufacturers time to provide compliant products, or sometimes even develop new ones if there's a clear market need and a gap exists. Building relationships with suppliers who really understand LE, who understand the documentation requirements, and can provide that robust backup documentation easily, that's invaluable. Saves so much time and headache later.
Makes sense. Partner with knowledgeable suppliers.
Definitely. Another best practice is strategic material selection. Instead of just trying to force every single item on the project into compliance, which might be impossible or incredibly expensive, understanding those pathways we talked about allows for a more strategic approach. If a particular material is proving really difficult or costly to source as low-emitting, a team might pivot their strategy. Maybe focus on achieving higher compliance in different categories where it's easier or more impactful, leveraging the flexibility of Path 2 and Path 3.
Don't bang your head against one wall if another path is open.
Pretty much. And finally, good documentation management. Using centralized documentation systems, whether they're sophisticated digital platforms or just well-organized physical binders, is crucial for managing the sheer volume of product data. Some teams find it really helpful to assign a dedicated materials champion on the project team, someone whose specific job includes tracking all this information, chasing down submittals. That can greatly streamline the process.
A point person for materials. I like that. Those are really tangible, actionable insights. Looking ahead now, how do you see this whole low-emitting materials landscape evolving? Are the new technologies coming? Or emerging health concerns we're learning about? Shifts in regulations, maybe, that might shape LEA v6 or even beyond?
That's a fascinating question because this field is absolutely constantly evolving. It doesn't stand still. We're already seeing trends that will undoubtedly shape future versions of LE and other green building standards. One major trend, I think, is the focus on material transparency beyond just VOCs.
Okay, looking past VOCs to what?
Well, while VOCs and formaldehyde are critical, there's growing awareness and concern about other potentially hazardous chemicals often found in building materials. You sometimes hear about red list chemicals or chemicals of concern. Things like certain flame retardants, phthalates in plastics, heavy metals, PFAS.
Right, a whole other alphabet soup of chemicals.
Exactly. Future standards might increasingly require manufacturers to disclose full ingredient lists, almost like a nutrition label for building products. This would allow designers to make more informed choices about a much broader range of potential toxins, not just the ones that off-gas easily. We're moving towards a more holistic understanding of chemical impact.
Full ingredient disclosure, that would be a game changer.
It would be huge. Another area of evolution is likely performance-based testing and real-time monitoring. Imagine buildings that not only start with low-emitting materials, but also continuously monitor their actual indoor air quality in real time while occupied.
Sensors in the building measuring the air.
Precisely. This could lead to more dynamic ventilation strategies, for example. Systems that respond to actual measured pollutant levels rather than just running on a fixed schedule based on assumed air quality. New, cheaper, more accurate sensor technologies are making this increasingly feasible. It takes some of the guesswork out.
From prescriptive, use these materials, to performance, meet this air quality level.
That's a potential direction, yes. And finally, I think we're also seeing a continued push towards biomimicry and truly natural materials. As we learn more about the potential long-term effects of synthetic compounds, there's definitely renewed interest in materials that are inherently non-toxic, renewable, maybe derived from natural processes without needing extensive chemical processing.
Like what kind of materials?
Things like advanced wood products, using innovative joinery instead of glues, natural insulation materials like mycelium mushroom roots or cork or straw bales, mineral-based finishes like lime plaster instead of synthetic paints. The goal is sort of moving beyond simply less bad materials and towards materials that are truly good for both human health and planetary health.
From low-emitting to actively health-promoting.
That's the trajectory, I think. This continuous drive towards safer, healthier, and more transparent material choices really underscores the ever-increasing importance and likely evolution of credits like LEED V5's low-emitting materials.
What an incredible journey that was, through the really intricate but clearly vital world of LEV5 low-emitting materials. From understanding that crucial intent protecting our health, protecting the environment through the strategic pathways to earn those points, down to the granular details of product categories, the rigorous scientific criteria, and even touching on the challenges and future trends, we've seen just how much thought, how much science goes into creating truly healthy indoor spaces. It makes it abundantly clear that that ubiquitous new building smell really is something we should consciously be moving away from, actively working to eliminate its potential health implications.
This deep dive, it really highlights that a building isn't just concrete and steel, right? Or even just energy performance, as important as that is. It's truly an ecosystem of materials. And that ecosystem directly, profoundly impacts our well-being every single day we spend inside. The choices made during design, during construction, they have really long-lasting consequences for human health, for environmental quality. The continuous evolution of standards like LEV5, it pushes the entire industry towards a healthier, more transparent future. It makes every single material choice a critical decision for health and sustainability, not just, aesthetics or structural integrity.
It's about designing buildings that actively care for their occupants.
Yeah, turning passive structures into active partners in our health. That's a nice way to think about it.
We truly hope this deep dive has given you a fresh and maybe deeper perspective on the spaces you inhabit every day, and on those invisible elements, those materials and chemicals that contribute to their quality, and maybe also on the dedicated efforts being made to improve them. It's a powerful reminder, isn't it, that informed choices in building, in material specification, can lead to really profound impacts on our health, our productivity, our overall comfort. Next time you're in a new space, you might find yourself thinking not just about the design, but about what's really in the air you're breathing and how it came to be that way. If you've enjoyed learning about this fascinating world and you want to continue exploring the hidden depths of various topics shaping our environment and our lives, please remember to subscribe so you don't miss our next deep dive into this world.